Today we're going to talk about L'Hopital's rule again. In the previous video we derived the formula for L'Hopital's rule, and in this video and in the following video we're going to discuss where we can apply this rule. So first of all, L'Hopital's rule can be used in two cases. For instance, we have a limit as x approaches a of f of x over g of x, and if we get the intermediate form 0 over 0, then we can use the L'Hopital's rule here in order to get a proper number for the limit. The other case is when we have a limit of some number as x approaches a of f of x over g of x, and we get the intermediate form infinity over infinity. Now today we're going to talk about this intermediate form when we get the result 0 over 0. So first of all, when we solve problems we have to check if we get the intermediate form or if we get another number. Also, it is very important to note that if we use the L'Hopital's rule one time and we get the same result 0 over 0, we can use again L'Hopital's rule in order to get the proper result. So let's start with an example. Here we have the limit as x approaches -1 of x to the power of 3 plus x plus 2 over x plus 1. Okay, so if we replace the x with a -1, we will get in the numerator, we will get here minus -1, here again -1 plus 2 over -1 plus 1, which will be equal to 0 over 0. So this is a proper case in order to use L'Hopital's rule. So we will rewrite this, the limit as x approaches -1 of x to the power of 3 plus x plus 2 over x plus 1. Now we have to find the derivative of each of these functions. If we imagine this as a separate function and x plus 1 as another function. But remember not to use the quotient rule. That is not the case in the L'Hopital's rule. So what is the derivative? So we'll get 3x squared plus 1, and the derivative of 2 is 0 since it is a constant. And in the denominator we have only 1. So basically the limit as x approaches -1 is 3x squared plus 1. And if we find the final result, we will get that it's equal to 4. Let's solve another example. In the following videos we're going to solve some problems using L'Hopital's rule. So now we have the limit as x approaches 0 of x minus sine x over x squared. Now here we can check and we will get the intermediate form 0 over 0, so we can go ahead and use L'Hopital's rule. So we have the limit as x approaches 0, and in the numerator we will get 1, let's see, minus cosine x over 2x. And if we replace for dx for a 0, you will get again the intermediate form 0 over 0. So we need to use L'Hopital's rule again. And what we will get this time? Okay, so the derivative of 1 is equal to 0 and the derivative of minus cosine x is equal to what? Now the derivative of cosine x is equal to sine x, and here the derivative of 2x is only equal to 2, and we replace the x for a 0, we will get 0 over 2, and the final solution is 2. So here we don't have to use L'Hopital's rule again, since we didn't get the intermediate form 0 over 0, but we got the form 0 over 2. So 0 is the final solution of this limit. In the following video, as I mentioned, we're going to see the intermediate form infinity over infinity.